Cool. Hi, I'm Brandon. That sounds really loud. I can hear myself quite a bit. It's awkward. Hey, I think we missed a part during the 101. I won't blame Tom. But what I will say is, how many people's first time is it here? Raise your hand. It's my first time. Sweet. If it's your first time, there are some stickers over there that are free, just for the first timers and everyone else, but feel free to grab them. So today, I'm going to talk about verification of HTML document subresources, otherwise known as subresource integrity or subresource integrity validation. It's kind of a boring concept, but hopefully I'll make it interesting for you. I didn't take that picture. It was a free stock photos. I'm trying something new with my presentation. I'd like some feedback. I'm using a lot of stock photos. I thought it'd be kind of fun. Some screenshots. I don't know that there are too many words on them. So this is kind of where the story begins. A few weeks ago, I was actually building up a new web application on the side for fun related to DEF CON, and I based it on Bootstrap. And so I went out to Bootstrap. So this is a screenshot of the getting started thing on Bootstrap. And I just kind of want you to make note of the JavaScript and CSS that they're like, hey, copy and paste this. It was very easy to start using Bootstrap. A couple days later, the Ticketmaster announcement came out that they had been compromised. And previously to that, there was a breach of Delta, Sears, Kmart, and Best Buy. And it wasn't actually, the commonality between these items aren't actually the fact that Ticketmaster was compromised or that any of the four companies on the left were compromised. What it actually is that there were third parties that were compromised, and ultimately Delta, Sears, Kmart, Best Buy, and Ticketmaster are client companies of these third parties. And so this kind of set me down this path of figuring out what actually happened. And around that time, this report came out by RiskIQ. It's a really good report. Like, it's actually a very exhaustive report and has tons of details. I can't give the two authors of this report enough credit. And so they described the attack that came out on June 27th of Ticketmaster. I provide the URL on all the slides that I referenced to it. I suggest that you go read it. Ultimately, they attribute the Ticketmaster breach to a threat actor that they call MageCart. And they describe their investigation of their postmortem, if you will, an external postmortem of this Ticketmaster compromise. And they come to the fact that is ultimately down here at the bottom, in which Ticketmaster and Ubuntu, which is the third-party company, mentioned only a third-party script hosted by Ubuntu. So effectively what happened here was, so Ticketmaster had a chatbot on their web server. On their website. And that chatbot was actually provided by a third-party company. In order to facilitate that, Ticketmaster loaded that third-party JavaScript, just like I did for Bootstrap, onto their page. And the threat actors actually compromised that JavaScript and injected what they call a skimmer into that page. And the skimmer is shown here. And every time that you post payment data at Ticketmaster, this JavaScript would run and would actually post your payment data to the adversary as well. This functionality, in some cases, they left the real script so it would maintain the normal functionality, and other times they ripped out the entire script, and the only thing it did was post to the adversary. And so what we're talking about here is this third party's code pipeline was compromised. And as a result of Ticketmaster trusting that third party and allowing them to inject code directly into the client's browser, the client as in Ticketmaster's client, they were ultimately, not only was the client a victim, but Ticketmaster themselves were a victim as well. Ultimately, the breach happened at this third-party chatbot provider. So how do we get together and fix this? Stock photo. So sub-resource integrity, or SRI, is defined with some common use cases. And the one I've highlighted here is exactly what we talked about. An author of a website includes JavaScript from a third party, and they want to do validation that that JavaScript has not been modified. So you can see the example of it here, where they're loading in a JavaScript. And they include this integrity hash, or this integrity tag, which includes the SHA-384 hash that's base64 encoded of the JavaScript. Your browser interprets this tag and won't load the JavaScript if that hash doesn't match. So when you import that third-party code onto your website, now you're given the option to control, to validate the integrity of that sub-resource. That's a blank slide. So there are some use cases where it doesn't work, though. Notice the stock photo. Internet Explorer doesn't have any support for the sub-resource integrity. So Internet Explorer will load that document regardless of you including that. There's an additional tag, which is actually it's a content security HTML header, or I'm sorry, an HTTP header. The content security policy require SRI 4. And so that is actually saying, on my web page, I expect all of my external JavaScripts or my CSS resources to have sub-resource integrity enabled for them. And if they don't have them enabled, if that integrity tag is missing, then don't load them altogether. It's important to note that this not only applies for external and third-party hosted stuff, but you can apply this to locally hosted as well. It's kind of like that last line of defense within your user's browser. It's quite an interesting place to put security controls. So this is an example of what Stripe tells you to use on their JavaScript. And notice that they don't include an integrity heading on here. And notice that they don't include as well as any version aside from v3 on this. So this is what I would call an unversion-controlled JavaScript library. So keep that in mind. We'll describe what that means in a little bit. So here you can see that coming back to that Bootstrap example, what those integrity tags are. The other thing that you'll notice here is, well, I don't know if you can see it or not, but is the version in here, 4.1.2 CSS, and then it loads the particular resource with that integrity. So this is a version-controlled resource, which means that every time that they update the version on their side, you have to update your code and apply the new hash. So this is kind of a gotcha, if you will. This is kind of where SRI doesn't work, where if you're like Stripe and you simply tell your users, just use the latest code, you can't version control it. You can't apply the hash because Stripe is changing their JavaScript code all the time. And so they don't provide you a methodology to do version control or even enforce SRI because that hash could change all the time. Whereas Bootstrap and jQuery, they provide you the ability to do so. So this is a quick 10-minute talk. I think I'm actually going to go under time, which is unbelievable. Version control your external code. So where you can, like jQuery does, it's version 3.1.1, and then you can apply that integrity tag to that version. If your vendors don't do this, like Stripe, demand that they do. The other option that you have is down at the bottom, is locally host and version control that code yourself. So instead of hosting that out on a third party, download it, host it locally on your own website or CDN or whatever it is that you need to do, and then monitor that library for updates and actually apply good change control methodology to that. And then obviously where you can, add your SRI tags within your HTML code. So in my opinion, this could have, pardon me, in my opinion, this very easily could have prevented the compromise both at Ticketmaster as well as all of those other companies, assuming, and it's entirely based on the fact that me as Ticketmaster can control my website and I can control the hash that is valid on my website, and I don't have to trust that third-party code that's being injected into that as a result of it. You might break some things, so as with any other change that you might introduce within your environment, test it. If you have Chrome, I tested this myself, and so in the console, like in your developer tools, it will just say, hey, sub-resource integrity did not validate blocking the resource or something like that. It was really easy to see in the console. So here's some of the resources that I have. If this is something of interest to you, I would recommend taking a picture of that slide. It's kind of got the details about that Ticketmaster compromise as well as SRI and that content security policy tag. If there are any questions, I'll take them, but it's a pretty simple concept. Sweet, didn't think so. I'll kick it off to a break and see you guys later.